Hello, my dear student. I am BS Pandey, your physics lecturer. Today we are in lecture number 21 of Kinematics. That is the third lecture of Kinematics, and we are studying motion in one dimension. Okay, that is the one-dimensional kinematics. My dear students, we have discussed so far about the distance displacement, average speed and velocity. Today we will discuss about the instantaneous quantity, that is the instantaneous speed and velocity. Okay, so let us start today's lecture. The lecture number 21. Of kinematics. One-dimensional kinematics, my dear student. Okay. My dear student, I have discussed few questions in last lecture. I have given a question to find the. Let me discuss this question because I got the comment from few students. Sir, it would be very much better if you will explain this question in the lecture. That the three students are moving A, B and C to catch each other with the same speed, alright, which is the constant, and we have to find where and when the student will catch each other. Okay, so I'm going to solve this question. The side of the triangle, it was given, I think A or L, I don't remember exactly. Suppose it is L, or it was the A equilateral triangle. Now, my dear students, look at it very carefully. As the student A will move towards the B, B is not in rest. It will also start moving towards C to catch him, and C will start moving to catch A. It means as soon as it will start moving, the student A will see that B changing its position and comes to this one. It means it will change its position slightly and slightly and slightly. Why? It is moving up. As he is moving towards the C, C is also moving forward, so he will also change its direction of motion, and C will also change its direction of motion. Finally, all three changing direction continuously and got each other like this way. It's not the perfect diagram, but they will catch each other at the centroid. Alright? It means they will follow this particular path. Now you have to find the average velocity. Okay? The question was to measure the average velocity. You have to find. Okay, how? So my dear student, the displacement of each of the students, you can see this one is the displacement of student A, and this was the student B and C. Alright, if this is the displacement OA, this will be the displacement. I hope you understand. If this is the displacement, then I think the question was to find the time. I'm sorry, okay? The time, not the average speed or velocity, the time. Okay, now the displacement, it is OA. Could you find this value? How much this OA is the center? Yes, we can find. This is the equilateral triangle, so this angle will be 30 degree. Am I right? This is 30 degree. And leaving the perpendicular this distance will be how much? It is a by 2. Suppose this is x that we have to find. If we'll break the component of this x over this axis, it is the x cos 30, which is equals to a by 2. X cos 30, which is a by 2. Now you are able to solve this. A by 2 cos 30, it is root 3 by 2, cancel out, so it is a by root under 3, and this is the value of x, a by root under 3. Alright, and this is the displacement, my dear students. This one is the displacement. Now could you find the velocity? If you have to find the time, so time equals to distance by, or the displacement, since it is on a straight line, so you can write the distance or displacement both the same. Distance or the displacement over velocity or the speed. Alright, and this velocity, the distance or the displacement, how much it is? A by root 3. Now the velocity. We know that the velocity along this direction, it is v. So the velocity along this direction will be how much? You can break the component along this direction. It is the v cos 30. V cos 30. And this will be t. It is a by root 3. A by root 3 over v, again root 3 by 2. Alright. So you can find out here the twice, it is v root 3 by twice a by v root 3, it is the 2, and this one is the 2 by 3 a by v, your answer. Okay, my dear students. So in this way you can solve all the question. Now my dear students, we'll move today for the next topic. It is instantaneous speed and velocity. So basically we are starting today's lecture with the topic instantaneous speed and velocity. Okay. Instantaneous speed and velocity. Okay, my dear students, we'll represent the instantaneous speed by v instantaneous and the velocity by the v instantaneous. Okay, we will use this symbol also, vt. If it is written the vt, it means the speed at any time t or the function of time t. V, it is the velocity. T, it is the function of t or the velocity at any time t. Okay, my dear student. We know that the average velocity or the speed, it was del x over del t. Okay, that is the velocity or speed. You can write the del x over del t. So the instantaneous speed or the velocity can be written at the limit value delta t tends to be 0. You are in standard 11th, my dear student, then might be you have not studied the limit and continuity. So try to understand. I am explaining you till here. In further, in very detail, you will study in your mathematics course. This can be written as the dx over dt. This is a very important, my dear student. Dx over dt. What does it mean by the limit of any function with the delta t tends to be 0? Actually, the definition of instantaneous speed or velocity, my dear student, is the speed measure or the velocity measure at any instant. Suppose if you are riding a vehicle, okay, if you are riding a vehicle and you leave your home at certain time with certain speed, but till the destination, I'm sure that you don't reach with the same speed. But whenever you see the speedometer of your vehicle, it gives you the speed with which it is running right now. That speed you are getting from the speedometer, it is instantaneous speed or velocity. Remember, this is not giving the speed with which it was moving 3 days ago. It is the speed of the vehicle right now it is moving with. Okay, so this is the instantaneous speed. It means if you have taken a long journey, so by sorting over the time interval, okay, time interval, and you have to sort. Suppose this is your journey. Try to understand, my dear student. The time started from here, the 0 second, and here it is time, suppose 10 minutes. Okay, it is 10 minutes. You have to find the speed at this point. It means you have to shorten the time and you have to shorten and you have to reach at this particular point. From both the sides you have to shorten the time and you reach at this point. What does it mean? It means the change in time you have done, the change in time, how much? It is almost 0. Delta t almost 0. It does not mean the time is 0, but the change in time, you are studying a very small and a very small time interval, but at which time it is not given. But this gives you the concept of a point at a particular time. This is not the very much time interval. The 5 minute is a long time interval, but the 4 second also a long time interval, but the 4th second it is a momentarily time or the momentary time, you can say. So delta t tends to be 0. It means you have been reached to a particular point, and this is the meaning of that particular instantaneous value. Okay, my dear friends. So this will be your working formula for the instantaneous speed and velocity. This is the speed or the velocity measured at any instant. Now let me do some question. Suppose if, and one more thing, my dear students, if you are having the displacement, then by differentiating this displacement you will have the instantaneous velocity. But if you are having this velocity, this vt, then integrating with the time t, you will have the displacement also. Okay, so this formula will give you the two things, from initial to final, from initial to final. This is the limits. We have discussed in very detail about this limits. Okay, the questions we should discuss. Let me discuss here the one question. Suppose, my dear student, you are having a position or the displacement which is the function of time, and it is mentioned in this way, 5t cube. Okay, 5t cube. You have to find the initial speed, the first second speed at 2 seconds, Of course, this is the instantaneous speed. Speed at particular time you want to know. Remember, here the Vt you can write dx over dt. You can differentiate. This will be how much? 5 times 3 t square, 15t square, and this is nothing but the velocity at particular time. Now, you have to find this initial speed. Whenever we talk about the initial speed, we measure the speed at t equals to 0 second. The speed is called the initial speed. Okay, my dear student, it is called the initial speed. So v at 0 second, it will be 0 meter per second. But if you have to find the speed, okay, this was the first question. Now the second, you have to find the speed at t equals to 2 second. So at t equals to 2 second, the v at 2 second, it will be 15 times 2 square, 60 meter per second. I hope you understand, my dear students. Now, let me discuss another question on the basis of this equation. If you have to find the average speed, alright, you got the instantaneous speed at any particular time. But if you have to find the average speed, then you need any two time. Average speed, it means from where the vehicle starts and till what you are willing to find the speed. So to find the average speed, let me wrap this one. Try to understand how you will find the average speed. I will solve 2 to 3 questions and you will get all the things. Now, this is not the proper data. Now the question, find average speed between t is equals to 0 second to 2 second. Alright, between 0 to 2 second, you have to find the average speed. We know that the average speed, it is delta x over delta t. Alright, and delta x, it is nothing but the x final minus x initial over t final minus t initial. My dear student, we will solve in next lecture the same type of question using the graph. Now, the final position, final time, it is 2 seconds. So x at 2 seconds will be, put the value in this equation, you will get the x. It is 5 into 2 to the power 3, and it is 5 into 8, it is 40 meter. Now x at 0, you will put the value 0, it will be 0 meter. Am I right? Yes. Here the time final, it is 2 seconds, and the initial time, it is 0 second. So the average speed, it will be 40 minus 0 divided by 2 minus 0. How much? It is 40 by 2, 20 meter per second. Okay, my dear students. So in this way, you can solve the average speed. Okay, now let me discuss another example. Student, if using this equation, someone asked to find the position and in which direction this particle is moving, could you solve? Could you tell me that in which direction this particle is moving using that equation? Yes, you can solve. Alright, now again you have to find average speed, instantaneous speed, all the quantity, but the equation is being changed. It is x t equals to t square plus 2 meter. You have to find instantaneous speed at 1 second. Alright, the first question. Then after we will find the average speed. The first question, let me find here you can see, if you plot the graph, the time, the distance, and this is the origin. At t equals to 0 second, you can see the particle is at 2 meter. Now, in which direction the particle is moving? As the t will increase, at 1 second, you can see at 1 second it will be in this direction. So, in this way, you can find the direction of motion of the particle. This is also very important to read the direction of motion. I have discussed. Now, we are going to find the the instantaneous speed at 1 second. So, the instantaneous speed at any time t second, it is dx by dt. X is t square plus 2 by dt. So, it is dt square by dt plus d2 by dt, and this pt can be written as 2t plus 0, that is 2t. Am I right? Yes. Now, my dear students, if you will be asked to find the instantaneous speed, that is the initial speed, it will be 0. Alright, yes, it will be 0. Now, but we have to find the instant speed at 1 second. So, at 1 second, the value will be 2 into 1. It is very simple, 2 meter per second. Now, we are going to change the question. You have to find the average speed using the same equation. Find average speed between 0 to 2 seconds. How you will solve? So, you can solve the average speed. It is x final minus x initial by t final minus t initial, and x final will be at 2 seconds. You can see here at 2 seconds, x final will be, that is x 2 seconds, it will be the 2 square plus 2, 4 plus 2, 6 meter. At 0 second, this will be here, if it is 0, then 2 meter. Okay, my dear student. So, we can write the average speed, it is 6 meter minus 2 meter divided by the time. 2 minus 0, it is 4 by 2 meter per second. I hope you understand this question. This is not very tough. Now, next question, my dear student. This one is the very important question. Right now, I am going to deal with you. But before that, I am going to give you a homework. The next question is very interesting and very important also. But this is your homework. X is equals to 2t square plus 2 meter. Okay, it is the instantaneous value. A, find V instantaneous at 2 seconds. Find, second one, the find initial speed. Third, find average speed between 1 to 3 seconds, and D, find average speed between 0 to 2 seconds. This is your homework. Okay, my dear student, the first homework. Now, one example I am going to discuss here, which is very important. Okay, if xt, the function of position, it is given 2t minus t square meter. Look at here carefully over this equation. It is 2t minus t square, and you have to find the instantaneous and average value. The instantaneous one you can find out easily. So suppose you have to find the instantaneous speed v instantaneous at 2 seconds, my dear students. Okay, so v instantaneous, it is dx by dt, and it is d2t by dt minus dt square by dt. It is 2 minus 2t. This is the instantaneous speed. Am I right? At 2 seconds, you will get, at 2 seconds, it is 2 minus 4, that is minus 2 meter per second. This is the velocity. Remember, my dear students, it is 2 meter per second. The speed, it will be the 2 meter per second. Now, if you have to find the average speed, then how you will solve this question? Try to think. If you can solve, you are having the time, pause the video and try to solve. You have to find the average speed between the question, average speed in 3 seconds. Okay, this is the question. You have to find the average speed using this one in 3 seconds. How you will solve this question? Try to think, pause the video and try to solve this question if you can solve. Okay, now let me solve this question. The average speed. First, using that equation, my dear students, what it was 2t minus t square. X was 2t minus t square. You can see, let me plot the graph, and this is the x. Alright, at 0 second, the particle will be at origin. Am I right? At 0 second, you can see the particle will be at origin. As you will increase the time, suppose at 1 second. At 1 second, you can see at 1 second it will be 2 minus 1, that is at 1 meter. Very good. At 1 meter. At 2 seconds, it will be, it is 2 to the 4 and it is 0 meter. Again, the particle goes in this way, but it return back in 2 seconds. In 3 seconds, if you will find, in 3 seconds, the particle will give you some other information, but it is quite obvious the particle getting turned from somewhere. It means at certain instant, at any time, the velocity will be 0. At which time the velocity becomes 0? Try to find out at which time the velocity will be 0. Here we are having the instantaneous velocity. So Vt will be 0 at which time? So if it is 0, then 2 minus 0 equals 2 minus 2t, and it is t equals to 1 second. At 1 second, the velocity is 0. It means for 1 second, the particle goes in one direction. Here, the velocity becomes 0. If it is velocity 0, then the particle return back. And how much distance it cover? In 1 second, it is 1 meter. You can see. If it is 1, it is 1 and 1 meter. But we have to find the average speed in 3 seconds. Okay, average speed in 3 seconds. So how much distance it cover after this 1 second? So the for 2 seconds, look at here, let me rub this one. In 3 seconds it will move. It was the equation 2t minus t square. So in 3 seconds it will cover x at 3 seconds. It will be minus t square. How much it is? 6 minus 9, and it is minus 3. It means particle goes further to this particular point, minus 3. Okay, my dear students? Yes. How much distance this particle cover? Look at here. 1 meter, 1 meter, 2 meter, and then 3. How much? 5 meter. So the total distance covered by the particle, it is delta x, it is 5 meter, and the total time taken by the particle, it is how much? 3 seconds. So this is the average speed. Okay, average speed in 3 seconds. Now, what will be the average velocity? Could you find average velocity? Yes. So the average velocity, from here the particle start moving, the 1 meter goes but 1 meter back, the displacement 0, the total displacement it cover, it is only 3 meter but in opposite direction, so minus 3 by the total time it took 3, so the minus 1 meter per second. This is the average velocity. Hope you understand, my dear students, the expression. Now, one more equation and one more question. My dear students, now this particular question I am giving you to solve by yourself. You will solve this question. Okay. Now, let me rub this one. Okay, my dear student. So, write down the next equation that you have to solve by yourself. And remember, this question is being asked in a engineering examination. This is the question you have to solve by yourself. It is your homework. This is t square minus 2t. I have been reversed the value. It is t square minus 2t. Okay, this is the equation. What we have to find instantaneous speed at 3 seconds. First, second one, instantaneous speed at 3 seconds you have to find. Okay, now average speed in 4 seconds you have to find using this question, my dear students. Average speed in 4 seconds. Remember, average speed, the same concept you will use, I have been taught you right now. Okay, now the next one, you can find here the third one is find initial speed. Initial speed. So this is I think we are running today with the time. So my dear students, in next lecture I will discuss few more questions on the basis of this instantaneous quantities. Okay, so this is all about today's lecture, my dear students. Thank you very much.